So besides our headquarters in the US, and we have two offices in Europe. One is our European office, which is located in England, in Bolton, which is very close to Manchester. And we have a direct sales office in Germany, which is located in Saarbrücken. This is at the border to France. And here is our technical center in Asia. It's located in Shanghai, and this is who I am right now. Okay, and QLab is known as a testing instrument provider for most of our customers. That is all, of course, that is true. But many customers may not know that besides we manufacture the testers, we also are global provider of testing services. We have our accelerated laboratory weathering test service in Germany, in US, Florida, and in China, in Shanghai. Okay, just like SGS and other third-party testing service, we're the same. And we have also a special testing service, which is our outdoor weathering sites. To be a leading company in the weathering and corrosion test field, we have to know both the machine and what happens in real outdoor. So these two sites, one in Miami, Florida, and the other one in Phoenix, it's not only a business to help to receive specimens from a customer and we perform the outdoor weathering test for them. It is also a research center to help us understand what really happens outdoor. And we also use the data, the real outdoor data, to support some international standards like ASTM D7869. Okay. So today, the topic of today's seminar is how to understand the weathering test correctly. So I would like to put the question here: why we perform laboratory weathering? We're gonna make sure that we answered most of you's more important question in the initially. Okay, the question is everyone may ask this question, which is how many hours in my accelerated test correlates to how many years to outdoor service. For my almost 6 year experience working in for QLab, I've been asked, I think, thousands of times from customers, okay, all over the world, okay? And here's the hard truth, which is there's no universal acceleration factor, or we call the magic number. Customer want to buy a machine. We call it like a magic box, which is you throw a piece of material in, and they will show information to you like, oh, this material will last for 3 years in Singapore outdoor. But this is not science. There is no such machine. So we have to know that. Okay. And why is that? That is because different materials in different service environment have different acceleration factors. I always make an example to customers. Hey, customer, today we have a red paint panel and a red plastic panel. Okay, they're both red, and we care about the fading. We test the delta E, the color change. Okay, but if we do accelerated test in a QUV, we will see, for example, 500 hours in cycle ASTM G154, cycle 1 equals 2 years in Singapore outdoor. This could happen. The color change is the same. That could happen for the coat for the paint panel. Okay, so let's move to the plastic panel. Also 500 hours in the QUV under ASTM G154 cycle 1. The color change could equal to 1 year in Singapore outdoor. So same machine, same test method, same color, and one equal to 2 years and one equal to 1 year. So which one is right? That I think this is a good example to tell everyone that there is no unique magic number. Every material, every specific material has its own accelerate factor, acceleration factors. Okay, so weathering and corrosion tests do not give quantitative predictions of service life. Oh, so we it's not because QLab does not do the research about that. It's just because the magic number just don't exist. Okay, but if we cannot know that, why we do weathering test, right? Many customers will ask their question. So let's see, there are different kinds of goals about the weathering test. Why we do weathering test? Okay, the first one is QC. QC is very simple. It's only pass and or fail. And for many customers, they have their internal data like any shipment, any lot of material when we about to ship, we need to do a test. For example, it's 500 hours UV QUV test. If it's pass, I will think, oh, the quality for this lot, this batch is okay. We can free to ship. And if this batch cannot pass the test, it means it might be some problem here, and we need to have further, investigation about it. So this is called QC. And the second one is qualification test. Qualification is mostly happen in electronics or in automotive market, because in the OEM of electronics and the automotive, they have their own standard. Like VW, they have their exterior standard and interior standard, and they have requirements for different materials, and they will require you to pass their standard, to pass their test. Okay, so this is both pass and fail. It's simple for you. Okay, and a little bit more complicated is a correlative test. Also, we call the comparative test. Why we do that is sometimes we have our R&D colleagues need to compare two specimens, the new formulation and the existing formulation, which one the weathering ability is better. Okay, in that case it's not that simple. It's not just a pass and fail. Okay, so in this one we need you to get the natural exposure, which means benchmark site test results like in Florida and in Arizona. Okay, and we call this use outdoor test to verify whether your accelerated test is correct or not. Okay, there are two level of information can get from the nature outdoor exposure. One is, does your accelerated test repeat exactly the same failure mode? Okay, like the color change or gloss change or cracking. The second thing is the ranking order data is okay. We have a ranking order data. If the correlation is one, which means, for example, we have one, two, three kinds of specimen in order. One is best, two is middle, and three is the worst. If we test in your accelerated chamber under certain test method, does that ranking order can repeat? If it's the same, which means the correlation is one, it's perfect. Okay. Actually, perfect is not that easy, but even it's only 0.7, 0.8, it's still good. Okay, because zero means random. Random means your accelerated testing does not give you any answer, any direction. Okay, so actually it's 0.6, 0.7, it's still okay, it's still good. Okay, so we call this to use natural outdoor data to verify whether your test method is correct. But once you have proved that this test method is good, is right for you, then you're free to go. Then you are free to go. You can compare your new formulations in the same chamber, and you can, if the new formulation's performance in the chamber is better than the existing product, which means in order, in the real end use, it's highly likely that it's gonna be better. Okay, and forget about the prediction. It's too complicated to get. Okay, so accelerated testing is a tool for decision making. It's only a directional decision making tool. Okay, so we can help you like what ingredients to include or not include into a product, whether a lot or a batch is okay to ship to customer. So we can help you to make a better and faster decision. It does not have to be a prediction tool. Okay, so next we will talk about the weathering outdoor and the weathering indoor. Why we make this type of machine? Okay, so first of all, you need to know your enemy. There are lots of different kinds of aging chambers, like temperature chamber, ozone chambers. They are not the same as what QLab made. We only care about three factors: sunlight, heat, and water, because these three factors will exist anywhere on the world. Okay, so like in Florida, it's sunshine, its temperature is high, and there's a lot of water. The humidity is really high in Florida. Okay, I think Florida and Singapore in Southeast Asia is pretty close. Okay, hot, wet, and sunshine. And there are other kind of climate in the world. It's like in Middle East, which is a desert. So it's also lots of sunlight. Temperature is high during the day, but lower during the night. And there is very fewer water. Okay. So first of all, let's talk about the sunlight. We know in the sunlight, actually more accurately, we should call it uh, radiation, because typically we think light is something human eye can see. So if we call the radiation is more accurate, because in the sun radiation will include the UV portion, visible light, and infrared. Okay, 7% of the sun, but in here we call sunlight means sun radiation. Okay, so 7% in the sunlight is UV, but actually this UV causes all polymer degradation. So we care about the UV portion a lot. Okay, this is the SPD of the sunlight called noon summer sunlight from the two standard organization. One is CIE and other one is ESTM. They both identify what is the noon summer sunlight SPD should be. So you can see here the cut on or cut off is like is in our definition is 295 nanometer for all door. Remember, it's all door. And 300 to 400, we call them UV portion. To 800, we call the visible light per portion. And after 800, it's called IR, infrared. Okay, so remember that we have outdoor sunlight and we also have indoor sunlight. So for some market like electronics, textiles, we always use the window glass, which means the sunlight goes through the window glass. The glass have a filter effect on the sunlight. So there are two main effect on the light. One is the cut on changes. If it's outdoor, it's 295. But if it's indoor, the cut on will be 310 or 320, depends on different kinds of filters or glasses. Okay. The other ones, the intensity will going down a little bit. So weathering test or the product can weather not only about the things people use outdoor, but also indoor, like the furnitures, electronic computers, displays, and the curtain, and the clothes, textiles. There are lots of application. Okay. The second one is heat. Um, Heat is something very obvious that when we have UV, we can break the chemical bond. So we call it is a photochemical reaction. So it's a kind of chemical reaction. We both know in, I think, almost all the chemical reaction, if we raise the temperature, the chemical reaction will speed up, right? So in the weathering test, the heat is the factor to accelerate the photochemical reaction, not the cause of the chemical reaction. Okay, if we only do research about the temperature, we have all the temperature humidity chambers in the market. It will be much cheaper. Okay. One thing you need to know is under the sun, in the real outdoor environment, different color can have different temperature. That is, we both know that if you wear black, when you're standing under the sun, you will feel hot, you'll feel burned. Okay. And there are some extreme temperatures, like inside a car. You know, in the summertime, when the outdoor temperature will be 40, even 45 degrees in the desert, if you seal all the windows of a car, it's likely that interior temperature of a car can go exceed 100 degrees. That's why in many automotive interior test methods like PV1303 or GMW 3414, the temperature setting of the xenon test is over 100 degrees because it actually happens. So in weathering test, the temperature it needs to go high because we want to accelerate the process, but it should not be too high. For example, if we test some outdoor interior material, oh, I want to speed up. I want test to be quick. So I set the temperature to 200 degrees, okay? And the plastic inside will melt. But this type of effect will never happen in the real end use. So the temperature setting needs to be high, but also needs to be reasonable. Water. Water is something that people we may ignore or forgot. Many people say, "Hey, I care about the color change and just no water, just only the lights." And lots of older version international standards only just do exposure. They don't care about the water. So water can bring chemical reactions and the physical effects. We also know that in plastic there are lots of additives, and some additives actually can dissolve in water. So some chemical reactions can happen in that situation, right? In the dissolve in the solution, and the physical effect is like thermal shock, because when it rains happens, the temperature will go down very quick and absorb freezing and thaw impact like wash effect. Sometimes the paint panel, they will have chalking on the surface. But if it's raining and the water can wash off the powder on the surface and exposure the fresh layer, and when the sun come out again, the weathering gonna go deeper and deeper. Okay. So there are different version, different status of water. And the first one is humidity. Oftenly we would describe it in relative humidity. Like we hear about the weather forecast, they always have data about today's relative humidity is like 60% to 80%, something like that. What rainfall is the most obvious thing, that it's raining during the day. It delivers lots of water and mainly about thermal shock and impact. And the most important thing, and the most people will ignore, is the dew, because dew typically happens during the night. And when the sun come out, the dew will disappear. So moisture from the atmosphere that forms in the form of small drops upon any cool surface is called dew. And dew have one special effect, is it will last on your specimen, will dwell on your specimen for a very long time. Okay, typically, like in Singapore, I will see it typically over 12 hours in one day. So look at it here. So this is morning in Florida in our exposure rack. So please check on the specimen. There's lots of water. This water is not rainwater, it's dew. So now dew, not rain, is the source of most odor wetness. So we also have a saying, which is if your product is designed to be used in odor, remember odor, which means you need to test your specimen with a water environment. Okay, odor is always wet, no matter it's raining or not. So here is a chart, example to show you what effect water can really bring to your specimen. Okay, we have a test chamber which is QUV and they use UVA 340, and irradiance is 0.83 and temperature is 50. And this is a coating panel, coated panel. We care about the gloss. The first test is moisture plus dark, which means only water, no UV, no sunlight. The gloss almost does not change. The second one is UV plus dark and dry, means only UV. Okay. And the third one is 100% UV, still only UV. You can see the gloss data is decreasing slowly. Okay, but you look at the UV plus moisture, the gloss reduced rapidly and we're going up. What happened to that? Actually, if you perform UV plus moisture, there is chalking on the paint on the coating surface. We know that if you measure the gloss, if there's chalking, the gloss will reduce very quick. So this example can tell you that the water will affect, not just affect the speed of weathering, but also affect the failure mode of the weathering. Because if no water, there's no chalking, only gloss loss. But in here, there's chalking. So if your coating, if this coating is designed for all door, if customer doing an old test with only UV, no water, and the result will cheat the customer. Hey, your quality of your product is okay. See the gloss, retention is really good. That is not true because the real end use, if you put into outdoor, the real effect will like this. It's terrible. Okay, so like I said, you always need outdoor data to verify whether your accelerated weathering test is the correct one or not. Okay, so this is a perfect example. Dew is not simulated in many accelerated lab weathering tests. Remember, in QUV, we have a condensation which can simulate the dew. But in QSUM, actually, there is no simulation of dew. Oh, sorry. So here I have a summary about the force of weathering, outdoor weathering. The first one is sunlight. Okay, it's very important because the UV of the sunlight actually causes all polymer degradation. That's why when we design our chamber, we care about the UV a lot. Small changes in material formulation or spectrum can have large effect on material degradation. For example, there are some plastic are designed for indoor use. They can last for the indoor environment, like the office light and or even the sunlight goes through the window glass. They can last very long. The quality is good. But if you put that plastic into direct outdoor, it will like fading or chalking or gloss loss very quick. Why is that? Because the plastic is designed for indoor. Indoor has indoor SPD. It's different from outdoor SPD. Okay, so when we talk about our Xenon, I will introduce you why we have different kinds of filters. Okay, heat. Heat in here actually is not the cause of the weathering test, but it's the acceleration factor of the weathering test. Water. Sunlight, heat plus water means weathering. When we talk about weathering, there's always water included because in outdoor there is water. Okay. Then let's move to the important part. It's the chamber. So I would like for you, the customers, to think about what I just introduced about the outdoor weathering. The outdoor, what is the weather like, and compare with what we have in the chamber. So this is a Xenon Arc chamber. There are two kinds of structure um, of Xenon Arc chamber in the world. For some of you that you may familiar with the rotating drum. QLab also have rotating drum tester, which is our XE2. Okay, in some market like textile, customer people, traditionally they would like to use the rotating drum, and QLab also have the rotating drum. And for most other applications like paint, uh, some plastics, actually we will recommend you to use a flat area like this one. Okay, let's see the difference between them. For this one, the lamp is in the middle, and your specimen will hang on it's like a drum, right? On the wall. Will hang here, and there's light monitor, and there's water spray nozzles. So the rack will rotating from the lamp, okay? And in our chamber, it's a flat area, it's a tray underneath the lamp. We have 3 lamp in our XE3. And we have water spray here, we have light monitor here, specimens, everything is here. What the rotating drum have, we have that in our flat area chamber. So many customer may ask a question, say, I think that rotating drum have better uniformity. That is actually another topic, but I would like to introduce you that actually we have done lots of research. If you are interested in that research, you can visit our website or send email to me. I'll forward the research paper to you. That is because by structure, we have a flat area, but we have 3 lamps, and we have a reflected chamber wall. So the specimen here or here, they receive the sunlight is not only about the direct sunlight from the lamp, but also, the light reflected from the chamber wall. This is the first point. The second point is we have 3 light monitors. And when we do calibration, we calibration 3 spots, which means left, middle, right, they both have the same irradiance reading. So let's check the rotating drum model. If customer only put the specimen in the middle layer, that sounds like it's pretty uniform, right? Because the distance from the specimen to the lamp are exactly the same. But the problems actually it's not a single layer. There are 3 layers. So in here and in here, the sunlight they have different angle and different distance. It's a little bit different. And the big part is about the water. See, if the water spray will spray to these 3 panels, and the water will go down to here. So the water delivery in the rotating drum tester is not uniform at all. Okay, so that's why in ASTM D17869 there is first time have the requirement of water calibration. They need to do calibration to see if the specimen receive enough water delivery. Okay, so if you are interested, this is another topic. Maybe we're gonna do a separated seminar later next year, maybe, and we to talk about the uniformity and test results about the 2 chambers. Maybe. Oh, I need to remind you that end of the webinar there will be a survey. We have a list of subtopics regarding weathering and corrosion, and you may need to take that survey to let us know that which topic you would like to hear. Okay, so this is the different filters Okay, this is a filter for XE2. I've told you that in XE2, in QSUN XE2, it's flat array, it's rotating drum. So the filter needs to be a cylinder, needs to like a lantern like this. The lamp will sit in the middle and the specimen will around it. And for XE1 and XE3, we have our flat array filter. It's like a piece of glass, but it's special glass. We have our daylight, windows, and extended UV families. So here is SPD about our daylight filter. Please look carefully. The black line here is the direct sunlight, which has been identified in CIE and ASTM standard. And we have our recommended uh, filter is daylight Q. If our Q sum, no matter actually 1, 2, or 3, if tester is using daylight Q filter, you can view the SPDs like this, the blue one. Actually, the cut on of the SPD is exactly the same as the real direct sunlight. So this is identical. Like I said, indoor and outdoor, only difference, the most important difference actually is the cut on. In outdoor, it's 295. Indoor is 310 or 320. Okay, outdoor and indoor. A little bit difference about the cut on can have big difference on test results. Okay, so when we design the filter, we want our cut on is exactly the same as real outdoor. That can give you a more reliable results. And then we have daylight BB. Daylight BB actually and the daylight Q actually they're the same. Just a little bit difference at the cutoff, 5 nanometers. Daylight F, daylight F in some area called the right light. The light is right. So I mean it's a very good SPD. But it's a new described in the ASTM D7869 in the new standard. They require daylight F. Use that ASTM D7869 is exterior test method for Ford, automotive maker in North America, the Ford. When they do the paint on the car, they need to test with ASTM D7869. And it's a very good test method. It's totally different from other like ISO 4892. It's totally different. We believe that this new method is a much better one to represent the real order. Okay, so check the short UV portion. And we have the window filter family. The window filter family have different kinds of filters, but one thing we are trying to achieve is we want our window Q, the cut on is exactly the same as real sunlight, ASTM 177, window sunlight behind the window glass. Okay, like this. And you can see there are some special filters like window IR. And for some of them, you may know that in the ink or in the textile market, customer may be very familiar with window IR. Window IR means infrared. They need to um, delete. You need to make the IR portion of the SPD disappear. So why is that? Why people need to, you know, why people don't want IR? Because in sunlight there is IR. That is because in some textile standard they require a lower temperature testing. IR can have the radiant heat for the specimen, so temperature will is very difficult to control. So if we filtered all the IR, the tested temperature can be lower. So for different application, the one we recommend is window Q or window BSL. So window IR is for textile, and window SF5 is a Ford interior testing method, requires a special filter. So SF5. Okay. And here is the special filter we call extended UV, QB or course. For some of you, if you are staying in the shoe market, shoe, the Adidas, the new one is released in 2018. Is called the FT11. The test method require extended UV course. Extended UV course, the SPD is like this, the blue one. But the real outdoor sunlight is a black one. See what change? What have changed? The cut-on is changing. They in, include a lot of short UV, UVB, which does not even exist in the real outdoor. But why they do that? Shorter UV, harsher environment. Okay, so they do that is simply want to accelerate the test or make a harsher environment compared with real outdoor. So that is okay, but it could cause unreliability or not sorry, unrealistic. For example, I have a material which is really durable. If you test it in the real outdoor, in the sunlight, it does not fade, it does not weather. But if you test under this kind of extended UV course, it will fail. It will, color will change, gloss loss, right? So this type of fail is only realistic because in the real use in outdoor, it does not fail. So this will cause the engineer, we call it over engineering. You spend more money and to make a very durable material, but actually it's not necessary. Okay, but there are some market like extended UV QB. Okay, it's for automotive. They also need a very shorter UV portion. They also want to do that because they have a higher requirement all about about their product. Let's imagine that if the customer's product can survive under this kind of SPD or this kind of SPD pretty well, and when they go back into the real end use, of course, their product will be okay because they have been through the even harsher environment. Okay, so in GM motor, General Motor, in General Motor, their exterior material and interior material, they both require the extended UV QB. They want the test to be faster and harsher. There's no big issue as long as you think it's your internal procedure. Okay. Filters for water-cooled lamp system need to be replaced every 400 for inner filter and 2,000 hours for outer filter. QLab does not manufacture any water-cooled system. QLab only have the air-cooled system. It's lower cost because you do not need to replace the filters. The filter is like a consumable for the water-cooled system. The cost, the operation cost is much higher compared with air-cooled. And the QLab's slogan is make the weathering testing affordable for everyone. So this is our goal. Okay. Almost all filters for air-cooled lamp system do not age or do not need to be replaced. We see almost because there is one filter needs to be replaced, which is the window IR. It's a different film on the IR, so it will fail over time, so need to be replaced. And customer for QSUN user need to check whether your window your filter, the glass, the piece of glass under the Xenon Arc lamp, whether it's clean or not. Sometimes it's pretty dirty. If it's dirty or lots of dust, obviously it will affect the SPD. So please check it and clean it. If it is foggy and it's like a lot of scratch on it, it's almost destroyed. So we will recommend it to you to replace it. Okay. So here is a solar eye control system. Actually, right now, all of the QUV or QSUN or other Xenon system. They both have the solar eye, they both have the irradiance control. But the difference is you can see the solar eye is our trademark. It's our trademark. Only we can use the word solar eye because we have the one button calibration. It's our only technology. So, which means the calibration is very, very simple for our machine. You just need to press the button and the calibration is done. Not like the others, you need to replace the lamp, put the specimen out, remove your testing lamp, and put a reference lamp, and doing calibration, and then replace the lamp to your testing lamp again, install all the specimens, and then running the test. Our calibration is like 1/5 the time consuming. Okay, and the one thing is need to be mentioned that is about the control point. We have 340, 420, and TUV. Many customers don't understand that what's the difference about different control point. Okay, there's only one thing. If you care about the UV, which means typically when your product is used outdoor, you need to care about UV, right? Then you need to select 340 nanometer control point. Okay, because 340 is sit in the middle of the UV portion. But some customer may say, oh, my product is indoor printing things for indoor, and I care about UV, but I also care about part of the visible light. Because you know when we do ink or printing materials, that the short portion of the visible light also have effect on the color. So I care about UV, but I also care about the short portion, visible light. I need to select the 420. But again, they both specified in the test method. In the test method, there is, requirement for certain control point. Just pick one. And this is the temperature control in the Xenon Arc chamber. And the temperature control, eh, these two things will sit together with your specimen. So they are going to represent the temperature of your specimen in the chamber, in the testing. But it does not have to be identical about the temperature because this is a coated black metal. It's steel. It's a painted black steel. And your product, your specimen might not be black or might not be steel. So because we have the sunlight, it's the heat radiation, different material, different color have different temperature effect. So this will represent the temperature of your specimen, but does not need to be identical. So what the difference between BP and IBP? First of all, in the standard, most ASTM requirements, I talk about the BP, American from American. Oh, sorry. ASTM announced themselves to be an international organization, not only for American. Okay. And for the IBP, IBP is commonly being used in ISO standard, or they call it black standard. What's the difference on the structure? This is black painted metal, and this is also black painted metal. But the difference is in here, they were equipped with a PVDF plastic. PVDF plastic, we call, you can stop the temperature to losing, from temperature from losing. Okay, so when these two panels will exposure under the sun, which temperature will be higher? I guess most customers will see this one. That's true, because when the temperature stabilizes in, for example, 70 degrees, why it is 70? That is because the chamber air temperature may be 45 and the BP temperature is 70. Why is that? That is because there's sunlight, the heat radiation to cause the temperatures to go up, right? But onto the panel, the heat needs to give out to the air, right? So in here, both sides can losing heat. The can, go to the air, both sides. But in here, only one side. So the balance temperature for the IBP will be higher than BP. Okay. So, but when you're doing test, just follow your test method, whether it's IBP or BP. Okay. And I need to um, make an advertisement that in our future webinar, we have one topic is talk about the temperature control in weathering test. We will talk about this type of question, this type of problem in detail. Okay, so to maximize acceleration, use maximum surface temperature. But to minimize error, do not exceed maximum surface temperature. So just like I said previously, needs to be high, but needs to be reasonable. Temperature, air temperature control. In Xenon Arc chamber, in XE2 and XE3, we have the ability to control the air temperature. Okay, and in some test method, in XE1, we can pick a BP control, black panel temperature control, or chamber air temperature control. We only pick one in our desktop model XE1. But in XE2 and XE3, we can control both. Okay. And the temperature, air temperature control is always related with relative humidity control. There are certain test methods that require the humidity control, like textile and automotive. They are required. And they have different type of humidifier, like boiler type system, which is our XE3, and the nebulizer system, which is our XE2. But remember, they can both control BP temperature, air temperature, and relative humidity. Okay. And the water spray. The front spray is pretty obvious. It can simulate the rainfall. Okay, front spray like rainfall. But many customers may ask, what is back spray? Back spray means, your specimen, one side will face the sun and the other side will have water spray. But why they do that? It seems stupid. Yes, it is stupid. And only one test method will require back spray for me, from my understanding, is the SAE J2725, 2527. The in the automotive OEM in North America, when they do the exterior testing, like the paint, they require the back spray. But why they do the back spray is because at that time, it's like decades ago, when they do evaluation, they want to simulate the dew, okay, like condensation. But how that can happen in a Xenon chamber, they think if they spray water on the back side of the panel, which will reduce the temperature of the panel. Okay, so there is temperature difference. And then in the front side of the panel, they will have dew. But we did research about that. There is no way. There is no dew on the front side. So just let you know that. But still, right now, for if you are doing automotive tests, especially for American automotive manufacturer, the exterior testing always require back spray. Dew spray is one simulation for the acid rain. It's also for automotive clear coat, automotive paint on the surface. So dual spray, which means we can spray two kinds of liquid. One is just pure water, and the other one is solution, the acid rain, soap, whatever. So you can pick one. And we have immersion. Immersion is like it's a water pan, and your specimen is immersed under the water, and there's sunlight. Okay, so there are several applications will require that, such as we have a standard called the ETAG 002, which is the curtain wall. In a tall building, there are glass on the wall, but the glass needs to use adhesive to glue it and to mount on the big building. So the glue needs to test on the with the immersion into the water. So this is just some. If you want to know more, just let us know. Okay. So we have the Xenon Arc Summary. I just mentioned one thing, two things. Okay, is the spectrum is full spectrum sunlight, the SPD. It's just the same as is it's just the same as sunlight. And as far as I know, the SPD of the Xenon Arc system is the best simulation for sunlight. It's much better than carbon arc. It's better than metal halide. This is the best simulation. Okay. The other thing is compared with the UV, the Xenon Arc system is always more expensive because it's more complicated. So let's talk about the UV. I think many customers has already know the UV pretty well. Okay. This schematic shows how our condensation happens. So there is a water pan here, and there is a heater. When we heat the water will become vapor, and there is a side door. There is a door, and we have a big gap. Oh, actually, I have a customer who ever talked to me. Hey, Tony, look at your chamber. It's not nice. Why is that? Because look at the gap. They have huge gap. Just like we buy a new car, if we see like the gap between the panels, if the gap is big or ununiform, I will say it's bad quality. It's bad quality. And the customer even say, hey, look at your chamber. The gap on the door is so big, it's not nice. I'm gonna say we did that in purpose because we want the room air, cool room air to go into the the door, and the specimen's backside will face the cool room air, and the temperature is lower. And inside of the chamber, the temperature is high and it's humid. Then there will be condensation happens in the front side of the panel. That is how the condensation happens. So this is a lamp. We have UV 340, UVA 351. Very few customer will use this because when people use UV, we want to accelerate the weathering process. But 341 can simulate the UV go through the window glass. And we have the UVB 313. UVB 313 is like more harsher. The cut-on is much shorter compared with the outdoor UV, just like this. See the UVA 340, 80 to 85% of our QUV users are using UVA 340 because it's the best simulation of the short portion UV. Short UV, it's the best simulation. The cut on is exactly the same as the daylight, the sunlight, daytime sunlight. Cut on is the same. And the short UV portion is also the same. The only difference is look at here the long wavelength UV, and the visible light is not the same anymore. And this is the UVB 330. It's much shorter, so it can have a quick result. Many R&D engineer need a quick result, so they do UVB 330. But again, I want to mention, if you want to maximize your acceleration, then you need to sacrifice the correlation. In UV system, there is no infrared, and there is almost no visible light. So the temperature difference for different color is not so obvious. Little bit, not much. And the condensation have lots of benefits because it's the closest match to nature wetness. Best way to accelerate the water in an laboratory testing. Okay, so they have lots of advantages. So we can do water spray. In here, water spray is to create erosion and thermal shock. Okay, and one thing for customers, actually, very few test method will require water spray in a QUV test. So when you want to buy it, please be sure that whether you need water spray or not. If you don't need water spray, you can save some money, thousands of US dollars. You just need a QUV SE. And you don't need a DI water system. That is because if you do water spray, the spray water must to be DI water. You need a machine to generate the DI water. But if you only do condensation, then you don't need the DI water system. You can use it if you have it. Is that perfect? But if you don't have it, you don't need to buy it additionally because it's condensation. Condensation water must be clean. And the only thing you need to do is clean the water pan regularly because you don't want to leave lots of fungi, uh, dirt into the water pan because the water is keep vapor. Okay. So UV, I give a simulation about best simulation of a short wave UV. Okay. So we have the pros and cons here. If you really care about SPD, for example, you are doing some ink and you care about the color change, you don't know which part of the sunlight will have an effect on the color. You don't know that. Then you probably need to pick Xenon because Xenon have the full spectrum, full sunlight spectrum. It could give you a reliable or more not reliable, sorry, more reasonable, realistic data because the full sunlight spectrum. But if you think water probably can give you your product a very important effect, and you care about the cost, then you probably choose the QUV. Okay, they don't fight. Actually, they don't fight each other. In many paint companies, okay, what they do is if they want to check the color, the fading of the panel, they will use the data from the xenon testing. If they want to know, like the peeling off, chalking, or loss of adhesion, this type of effect, they will use the data from the UV. So they're not competing with each other. They're just helping each other. It's like this machine can give you some characters about your specimen, and the UV can give you some else. Okay, so this is what we always say. They're not competing with each other. So in the last, I'm excited to introduce you about our E model and Gen 4 main controller. That is because QLab testers are now a brand new model. We have lots of improvements. So today I will introduce you the key improvements. First thing, you can see from the picture here, we don't have the button anymore. Right now we have the dual touch screen plus a LED light, the light. See, both QUV and QSUN. Okay, so let's talk about the QSUN. We call the E model. First of all, in the future, you will not have the XE3HS. There's no more. There's only XE3HSE plus E because it's new E model. The XE3HS does not existing anymore for most of you. Okay. All the QSUN E model will have the Gen 4 controller. Gen 4 controller means the two dual touch screen. The touch screen, it works really good. It's really nice. And also the other biggest biggest improvements is our lamp. Right now we have the X1800 plus lamp for XE1 and XE3. In the past, it's X1800. And right now we have the plus. What has been improved? First of all, in XE and XE3, in the past, when we do test on the daylight Q 340 nanometer control, the maximum irradiance setting is 0.68. right? 0.68 is the maximum. It can cover 95% of the international standards. Typically, the standards will only require like 0.35, 0.51, or 0.55. The maximum for our chamber in the past was 0.68. But right now, we can do 1.1. So it's much higher, okay? And if you use 420 control, it's also in the previously it's 1.5, and right now we can do 2.4. We can do 2.4 at 420 nanometer control. This is one thing. The irradiance set point, the range can be much higher. The first thing. The second thing is if customer is using the normal irradiance set point, like 0.68 or lower, we will give 3,000 hours warranty for the lamp life. Remember, in the past, it's 1,500 hours. So we doubled the lamp life. Of course, our price of the lamp will increase by 50%, but the life of the lamp will increase by 100%. So this can help the customer to reduce your operation cost. Okay, there's still a big improve. So for the XE1850 plus lamp, it will be used in XE2 testers. It's the same. The difference is in the past, the maximum set point is 0.68, and right now it's 0.8. It's a little bit increased. And for the lamp life, also 300 hours lamp life warranted. Okay, warranted for the normal set point. And if you do maximum irradiance set point, we give you 1,000-hour warranty lamp life. So this is a big improve. Okay, remember, only with E model plus the XE18 or 1850 plus lamp. This combination can have high radiance and longer lamp life. So this is a Gen 4 main controller. It looks like this. You can control that with your finger. And there is a big LED light. See here? So this light, they can change the color to the red, purple, blue, green, different colors, and it will go static or flashing. Different status of the indicator will tell you different status of the chamber. So especially in a chamber, in a lab, when you have multiple testers, you just look at the testers, see the different colors of the indicator, then you know what happened. This one thing. The other thing is a big improvement. Also can help a customer to save money is when you have the Gen 4 controller, you have two touch screen, right? You will not need the UC1 handheld display anymore. You don't need that because that is just a display. We have two screens. Do we need another display? No, we just use the display on the chamber, which means if it is your first purchase, when you buy the machine, in the past, you're gonna buy your calibration system, like the UC1 handheld display, and plus the temperature sensor and the irradiance sensor. Right now we call the smart sensor. But right now you don't need to buy the handheld display. The UC1 is not needed. The UC1's price is over $1,000. Then you don't need to pay for that anymore. So right now when you do calibration, the only thing you need to do is plug the sensor into your tester, the machine, and mount the sensor, and then you are free to go. For the QUV, first of all, we have the QUV 340 or 313 plus lamps. Okay, so the thing for the 340 plus lamp, in the previously, the highest set point is 0.55 for 340 nanometer, so for 340 lamp. But right now, we can do 0.7, even higher. And also we can give you 1,000-hour warranty if you're doing high irradiance test. Remember, in the past, we see our lamp have 8,000 hours use life, lamp life, but that is just for normal irradiance setting. We don't provide any warranty for high irradiance set point in the past. But right now, if you use a plus lamp, we will honor you 1,000-hour warranty for high irradiance set point. But many, I think 95, maybe 98% of the customer, they only do the typical regular irradiance setting, like based on ASTM G155, it's 0.89, or ISO 1.77. You do not need the high irradiance setting. So regular, the non-plus lamp are still existing there, and the price are the same. Okay, the price is the same, no difference. And for the UVB 313 lamp, we can also do a high irradiance setting. Okay, but I think very few people using UVB 313 or even UVB 313 high irradiance setting set point. Very few. So if you have the require, please contact our distributor Maha for more information. Also, we will soon introduce our UC101 smart sensor. What is UC101 smart sensor? Remember, in the QUV, I think everyone knows that the QUV needs to do the irradiance calibration, right? 1, 2, 3, 4, 4 spots to do the calibration to check. We require you to do the check every 500 hours. But how many of you know that the QUV needs to do the temperature calibration, just like the QSUN? And in our operation manual, it is required every 6 months. But I know that the reality is in the field, many customers will ignore that. I know that. So I'll give you some information about our improved temperature calibration of the QUV. Okay. Previously, we do this one. It's not convenient. You need to do a isolated jug or bottle and put some warm water, like 50-degree or 60-degree warm water inside. And you need to disassemble the temperature sensor in the chamber, in the QUV, and put the sensor into the water. And you need to have a reference thermometer, like here, and put them into the bottle together. And if your reference thermometer's reading, for example, is 63, okay, and your machine's reading is 60, which means your machine's temperature reading is incorrect, and you need to put in the P4 expert parameter to insert the 63-degree manually, and this is the calibration system. But right now, you don't need to do that anymore. In this way, in the old way, actually it's not correct. It's not precisely. It's not 100% precise. But in here, guess what? Our temperature sensor is in here, for the QUV is in here, right? But right now we have an identical panel. It's exactly the same as the temperature sensor in onboard temperature sensor. It's identical. And you put it here. Also use your UC1 system, or if it's a Gen 4 controller, you just need to insert it into your chamber. Okay. And when the temperature is stabilized, there's a reading in the UC1 system, and you can manually insert the data into your chamber. So that's down like this. Okay. After temperature has stabilized, the onboard sensor can be calibrated either directly on the Gen 4 screen or using UC1 and enter the value in P4 expert parameter. Okay, that's down. That's down. That's much easier and and the result is more reliable, not reliable, because the same structure compared with your onboard sensor. So this calibration, it makes sense, make better sense compared with the old one. Okay, so do remember your temperature of the UV still need to be recalibrated.